So the lecture is by tribute to Professor Shah, who served Department of Chemistry, Institute of Science, Mumbai, and made significant contribution to heterocyclic chemistry by synthesizing various type of nuclei. Uh, the topic of this brief presentation is chemistry of azoles, synthesis, NMR spectral study, biological evaluation of some azole derivatives. The five-membered aromatic compounds containing one or more heteroatoms, at least one of which must be a nitrogen atom, are known as azoles. Depending upon the number, type, and the position of heteroatom in this nucleus, we can have different type of azole derivatives. As far as the sources are concerned, majority of azoles are synthetic. However, some were isolated from the natural sources. These are some recent reviews on the naturally occurring azoles. Azoles are associated with various biological properties. So, in this review of that, the present work reports the reaction of aryl or heteroaryl hydrogens with aryl trifluoromethyl beta diketones, alpha acyl benzyl cyanides. The second one involves the solvent-free one-pot regioselective approach for 3,5-dimethyl and phenacyl pyrazoles or 4-substituted 1,3-dimethyl pyrazoles. Third one, the reaction of some thiocarboxamide with phenacyl bromides, reaction of some thiourea with phenacyl bromides, and the reaction of hydroxylamine with aryl trifluoromethyl beta diketones. Characterization of isomers wherever needed, using NMR spectroscopy, particularly proton, carbon-13, and fluorine NMR spectroscopy, and the biological screening. Related to pyrazole, the first part involves the reaction of aryl or heteroaryl hydrogen with aryl trifluoromethyl beta diketones. The reaction of N-substituted hydrogen with beta diketones yields pyrazoles, and one of the most common methods to prepare pyrazole compound. The problem with this reaction is that in case of unsymmetrical beta diketone, the reaction yields isomeric pyrazole. However, the situation becomes somewhat different in case of fluorinated substituted beta diketones, where along with the isomeric pyrazole, we get the 5-hydroxypyrazolene. So, in order to explore the effect of these substituent R on this in hydrogen and this R dash in case of diketone, we plan to study the effect of substituent present on the aryl trifluoromethyl beta diketones and hydrogens in the formation of products in neutral and acidic media. So, the reactant used here, the 6 beta diketones which are para-substituted, and these 5 hydrogens with different electron withdrawing nature. The reaction of beta diketones with phenyl hydrogen in neutral medium yields 3-trifluoromethyl pyrazoles as well as pyrazolene only in one case when this R is nitro. However, in case of acidic medium, always we get 3-trifluoromethyl pyrazole. In case of para-nitrophenyl hydrogen, by increasing the electron withdrawing effect here on the hydrogen moiety, we get pyrazolene in all the cases. So, you can see in acidic medium only we get 3-methyl pyrazoles, and the ratio of these two compounds in neutral condition was determined on the basis of the proton NMR spectroscopy. So, here you can see in case of nitro, this 3-methyl pyrazole is 90% and the hydroxypyrazolene is 81%. However, it is somewhat less in case of methoxy, 70-30. By increasing the electron withdrawing nature of hydrogen, we consider these some heteroaryl hydrogens, and in neutral medium we obtained only 5-hydroxypyrazolene. However, in case of acidic medium, we get only this type of 3-trifluoromethyl pyrazole. These compounds, trifluoromethyl pyrazoles, can be easily distinguished on the basis of proton NMR spectroscopy. See here, this proton plays an important role in distinguishing these isomeric pyrazoles. If this CF3 is present at this position 3, then this proton signal appears in this range 6.8 to 6.9 ppm. However, in case of 5-trifluoromethyl pyrazole, this signal appears in this range somewhat downfield. So, on this basis, we can easily distinguish these two isomeric compounds. And in case of the hydroxypyrazolines, we obtained such type of peaks 3.7 doublet and 3.5 doublet of doublet due to these diastereomeric protons. Carbon-13 NMR is also of much importance in distinguish the isomeric pyrazoles. In case of 3 substituted pyrazoles, the third carbon appears here in this range 143 to 45 ppm as a quartet. And in case of 5-trifluoromethyl the carbon appears in 133 to 135 ppm. So you can easily distinguish these two isomers on the basis of the signal of the third and the fifth carbon. If it is this methyl, trifluoromethyl is present at this position, obviously it will resonate in this range. So it is quite easy to find this structure of this compound as this carbon, this one tetrahedral carbon appears on this range due to the electron withdrawing effect of these two groups. This is the mechanism proposed, and the results of the studies. In case of the presence of electron withdrawing group, the ratio of the hydroxypyroxylene increases in this case, you can see. And on the y-axis, as you increase the electron withdrawing nature, again the hydroxypyroxylene increases. So as you move from neutral to acidic medium, we get only 3-methyl trifluoropyrazole. The second part involves the reaction of heteroaryl hydrogens with some alpha-acyl benzyl cyanides. Here we get the 5-aminopyrazoles, and in one case where this R is trifluoromethyl group, we isolated this intermediate also. The reaction in principle may yield the two isomeric products 5-amino and 3-aminopyrazoles, and we can easily distinguish these 5-amino and 3-aminopyrazoles on the basis of proton and fluorine NMR spectroscopy. In case of proton NMR spectroscopy, this proton, when it is H, so it appears at this value 7.6. However, if it is present on position 5, it appears 8.7. So by looking on these two positions, these two signals, we can easily distinguish these isomeric compounds. And if this trifluoromethyl group is present at position 3rd, it would resonate at -62. However, at position 5, it would resonate at -58. So on the basis of fluorine NMR, we can easily distinguish these 5 and 3 isomeric compounds. On the basis of carbon 13 NMR, if this amino group is present at position 5, then the signal appears in this range 146 to 147 ppm. However, when it is present in case of 3-aminopyrazoles, it would resonate 156 to 157. So looking at these two carbon signals, we can easily distinguish the isomeric compounds, and we established that our synthesized compound was 5-aminopyrazole. So these are some results of the antimicrobial activity of these aminopyrazoles. Here you can see when you change this group from this side to this side, there is a loss of activity. However, insertion of trifluoromethyl group on the pyrazole 3rd position again increases the activity. And if you move from this benzothiazolyl heteroaryl group to pyrimidyl group, then again the activity increases. So the results of the studies are reaction of the heteroaryl hydrogen with alpha-acyl benzyl cyanides always provides 5-aminopyrazoles. NMR spectroscopy has been proven to be an elegant tool to distinguish the isomeric products. Many of the aminopyrazoles have been found to display excellent antibacterial activity against some gram-positive and gram-negative bacteria. The next work involves the solvent-free one-pot regioselective approach for 3,5-dimethyl pyrazoles. On the basis of some dimethyl pyrazole or some acyl azoles, pyrazole or imidazole, we decided to plant such type of compounds, acyl pyrazole. So in order to synthesize these compounds, we came across the two reports in the literature. The first one involves the reaction of dimethyl pyrazole with this phenacyl bromide in the solvent medium, and it takes 110 hours to make this compound. However, in case of the other report by Santosh and co-workers, there is a multi-component solvent, one-pot solvent mediated approach, so it needs lesser time. So that's because of time constraint, we selected this approach to synthesize our compounds. But unfortunately, when we performed the reaction, we obtained 4 spots in TLC in this case. So that's why we explored the condition, and finally we synthesized the compound exclusively here by selecting this approach. Here first we added this hydrogen to this beta diketone, then in the same part we added this phenacyl bromide in the presence of this sodium carbonate, and the reaction takes only 8 to 15 minutes to complete. So as in this case, in this pyrazole, we have 2 nucleophilic site and the 2 electrophilic site in the other phenacyl bromide. So we may have this type of compounds here. Out of these possible compounds, we got this type of compound only, the structure type 1. That's why we are saying the reaction is going regioselectively. The compounds were further characterized on the basis of proton and carbon-13 NMR. Biological evaluation, in case of antibacterial activity, only the one compound, that is 4J with 2 naphthyl derivative, was found active. However, in case of anti-cancer activity on this human A549 lung cancer cell line, 4K and J exhibited similar potency as the carboplatin, a clinically used drug in inhibiting cell viability at this concentration. Effect of the compounds on plasmid DNA under the UV radiations showed that the compound 4C and 4D resulted in the complete DNA degradation even at 1 microgram. See here, C and D. So this is the substitution pattern versus biological activity. In case of 1 and 2 naphthyl substituted compound, the activity increases. However, in case of these activity decreases in 2 cases, 2 substituted naphthyl. In both the cases, means naphthyl derivatives anti-cancer property increases. So the results of the studies are a novel, mild, rapid, efficient and highly radioselective one-port synthetic protocol has been developed. The compounds 4J emerged as potent antibacterial agent. The compound 4C and 4D emerged as DNA photocleaving agent. And the compound 4J and K have the potential to be developed further as cancer therapeutics in the future. So we have filed 2 patents from this study and they published the work in the EGMC. Inspired from the earlier approach, we designed the 4 substituted acyl pyrazoles, and by using the same approach, we were able to achieve these compounds easily. So we characterize the compound on the basis of proton NMR and carbon-13 NMR spectroscopy. And here, in the biological evaluation, the compound 3M was found most potent antibacterial agent among the series with MIC 25 to 50 microgram per microliter against these species. And the compound 3G, 3O, 3P emerged as good antifungal agents against Candida albicans with MIC 25 microgram per 100 microliter. In case of DNA photo cleavage, only the one compound, it is showing the DNA protecting ability here, because this one is our DNA in absence of UV and this one is DNA in presence of UV, and you can see here the DNA remains same as present in this case. So means this compound is protecting our DNA. So this is the overall substitution pattern of this, and the results of the studies are solvent-free and mild approach again has been developed for some other derivatives for substituted pyrazoles, and some compounds were emerged as antibacterial and antifungal agents, and compound 3E only displayed the excellent DNA damage protecting activity, and this work has been published in NCR. Another approach related to thiozoles involves the reaction of some thiocarboxamide with various phenacyl bromides. Here, to synthesize such type of compound, first we adopted this approach in the solvent medium, but unfortunately we got these 2 products which were confirmed on the basis of proton NMR. So that's why we look forward to see the mechanism of this, and then we found that Singh and co-worker, they reported already the cleavage of such type of compound in acidic medium. So to stop this cleavage, we performed the reaction in bicarbonate under the grindstone method, using grindstone method by providing some heat also. So we were able to prepare such type of compounds, and the compounds were further characterized on the basis of their NMR spectral data. Here you can see this is the characteristic peak of this thiazole, 7.21 ppm. Okay. So these are some biological results, and this one is the substitution pattern and the results obtained from these studies. The mild approach, solvent-free and mild approach has been developed for the thiazole, and 3L and K emerged as most potent antifungal agent. The compound 3J displayed excellent DNA damage protecting activity. The next series of the compound involves the reaction of some oxazolidinone containing phenylthiourea with the various phenacyl bromides. Here we decided to prepare some thiazole containing thiazolene moiety, and we prepared this compound using sodium bicarbonate in presence of ethanol, and the compounds were characterized on the basis of their spectral data. So these are the biological results of the compounds. Here you can see for F, G and H, they are showing a very good activity against fungi as well as some bacterial strain. And this particular compound 4I, it is showing a good activity against bacteria as well as fungi. So the compound 4I was emerged as the most potent antibacterial agent. However, the 4F, G, and H were also found to exhibit significant activity. In case of photo-DNA cleavage activity, the results are very interesting. All the compounds of the series, they are protecting the DNA. Here, you can see. So these are the some antioxidant results. So the compound 4D and 4J, they found more active when compared with ascorbic acid as standard. So these are the results. Some oxazolidinone thiozoles based compound 4A2M have been synthesized, and some compounds were found more, you can say, biologically active compounds. The next part involves the reaction of aryl trifluoromethyl beta diketone with hydroxylamine. Here, Sloop and co-worker reported the reaction of beta diketone with hydroxylamine, a binucleophile species, results the formation of two compounds. They reported these two compounds, and they reported the value of this fourth proton. Both the protons appear at this range, 6.4. So the question was, how for both the isomer 4H resonates at the same value? So that's why we decided to reinvestigate the reaction, and we performed the reaction at the different pH values, and we found that the compound is 5-hydroxy isoxazoline instead of the 5-trifluoro isoxazole. Again, we came across another report where the author reported again the 3-trifluoromethylpyrazole using this Z, which is diazo compound. So again we reinvestigated the reaction, and we found that again we got the same similar product as we obtained in the earlier studies. So the structure of these compounds were characterized on the basis of proton and NMR easily, as we got the signal at 3.49 doublet and 3.7 doublet for these two protons. And this isomeric compound can be distinguished on the basis of the signal of this fourth proton, because in case of 3-trifluoromethylpyrazole, this proton appears at this value. However, in case of 5-trifluoromethyl isoxazole, it appears at this value. So we can easily distinguish these compounds. Fluorine, NMR, and carbon 13 NMR is not of much helpful in distinguishing these compounds. And this one is the mechanism of this compound. And the results are earnestly reported structure of the products have been corrected, and the reaction of beta diketones with hydroxylamine normally results the formation of 5-hydroxy trifluoromethyl isoxazoline under the different sets of conditions instead of 3-trifluoromethyl isoxazole. Finally, I acknowledge DST CSER for financial help, Mass Spectrometry Facility USA, and Professor Singh, my teacher, my mentor, Professor J.L. Guro, Sanj, Claremont, for providing some NMR facility, our research students, and these faculty members who helped us in exploring the biological activity, and finally my parents, teacher, and thank you.
Okay.